Welcome to week 2 of the Fungal Materials Workshop. My name is Jason and I'll be walking you through the lesson today. You can get resources and references for this lesson and the other lessons in the workshop at fungalmaterials.org/2018-workshop-1. Check out our Facebook group for discussions and questions at fungalmaterials.org/group or searching on Facebook for fungal materials and biofabrication. You can also shoot me any questions you have at jason@echolakeresearch.org. In today's lesson, we're going to do a quick review from last week about how fungi transform materials. We're going to talk about textiles versus what we're producing now, biotextiles. And I'll walk you through how to make kombucha textiles and how to prepare grain spawn, which is going to be the first step in working with mycelia. We'll go over the next lesson and I will leave you with some homework. So first, how do fungi transform materials? Fungi are more than just mushrooms. They exist as mycelia, long, tough, thin little threads that can weave themselves into meshes and tie things together. So if you have, say, straw that's loose and then you grow mycelia through it, that fungal tissue can bind the straw together and make it tough and hard. Or if we grow thin layers of pure mycelia or with a flexible substrate, then that can become something more like a textile. All right, textiles versus biotextiles. So what's a textile? According to Wikipedia, a textile is a flexible material consisting of a network of natural or artificial fibers, yarn, or thread. So this is the stuff that we weave. We take fibers from some natural source, or in modern times some artificial source, long, thin fibers, and we manually weave them together to make fabric and cloth. A biotextile is kind of similar. I'm defining it as a flexible material consisting of a network of fibrous elements woven together biologically. This picture is of fungal mycelia, and you can see these mycelia are fibrous and they're interwoven and interconnected, but we didn't weave it. The fungus wove it. One important difference between textiles and biotextiles is that typically the texture of a biotextile is much, much, much finer. This image of fungal mycelia was taken with a microscope, and you don't need the microscope to see threads in a piece of cloth that was woven by humans. Biotextiles can be grown to be thick and tough like leather, or they can be grown very, very thin and soft. It depends on what species we use to grow them, how we grow them, and the substrates and nutrients that we provide them with. I'm going to give a quick overview of the process of making kombucha textiles, and there's a detailed recipe and some more resources at fungalmaterials.org/kombucha. I'm going to take this approach so that we can make these videos a little bit shorter and lighter, and then for the references while you're actually doing these things, you can pull up the website and there'll be a list of steps that you can walk through. Kombucha grows as a biofilm on top of a liquid nutrient solution, which is essentially just tea. And actually, it literally is just tea. We feed kombucha with sugary tea. So you prepare the tea, you inoculate it with some kombucha culture, either a little bit of kombucha liquid or a SCOBY from a previous batch, and let it grow. The word SCOBY comes from symbiotic colony of bacteria and yeast. This isn't a pure fungal culture. It has bacteria and the fungal component of yeast. So we'll let it grow for typically a few weeks so it can get thick enough. Optionally, when you're done, you can dye the SCOBY with some kind of coloring agent and then dry it. In the process of drying it, it will shrink and become much thinner and tough. In fact, it becomes too tough, so we have to do something called plasticizing it, which is softening it up. We aren't actually going to turn it into plastic, at least not the kinds of plastics we think of when we hear that word. We can do this by working in some oils and waxes to soften it and make it flexible. You can also use glycerin, which is sometimes used to rework leather, traditional animal leather. It has some very, very desirable properties for this kind of work. If you use glycerin to plasticize your kombucha, it doesn't get tough or gummy, so the protection offered by the glycerin can extend for a long time. In addition, if you're using glycerin or oils and waxes, that confers some water resistance to the SCOBY. If you have an untreated SCOBY, it will suck water up like a sponge. I've read that kombucha SCOBYs can absorb 100 times their weight in water. If we're making items out of this, we probably normally don't want that. So it's important to treat it with some kind of plasticizing agent. And there's so much experimenting to do. One of the things that I'm most interested in is incorporating other elements into SCOBYs. They grow from the top upwards by layering on new layers of SCOBY on top. So you can put something like string or fibers or fasteners or even paper. You can put things on top of the SCOBY that's growing, and they will become enveloped by the SCOBY and part of it. If you do experiment with this, just keep in mind that the SCOBY will shrink some when it dries and it will flex during use. So if you have rigid elements or something like metallic wire, those are likely to either cause a tear or pop out and come loose. So you want to use ideally flexible natural materials if you're incorporating them into a SCOBY. And again, I put a recipe for growing kombucha and processing into a textile at fungalmaterials.org/kombucha. Now we're going to talk about preparing grain spawn. I'm putting up more details at fungalmaterials.org/grain-spawn. This is what we will use to inoculate bulk substrates with fungal mycelia. This is the first step in growing myceliated materials like structural bricks or insulation, and in some applications potentially we'll be using grain spawn to make mycelial textiles as well. The first step is to get some kind of whole grains. Brown rice is a common option. Rye and oats, if you can find those, are typically inexpensive and easy to work with. You can also use wheat. You can use pretty much any whole grain. You want to put the grains in water and then bring it to a simmer on your stove and stir every minute or two and check them. We want the grains to become hydrated, but not overhydrated. So as soon as the grains are just starting to be tender, drain them. If they're overcooked, they'll split and become gummy. Once you're done simmering the grains, you spread them out to dry. Try to have a thin layer and stir them every few minutes while they're drying. We do this because otherwise when we fill the grain jars with the grain, the additional moisture can make it much more likely for bacterial contamination to take place and wreck the grain spawn batch that we're trying to make in the jar. Because the grains are hot from getting simmered, they'll steam dry fairly quickly, probably 20 or 30 minutes, and they'll be ready to go. Take your wide mouth mason jars and fill them about 2/3 full. You want to have a little bit of space so that you can shake the grains around, but you don't want to waste too much space. Cap the jars with your airport lids that you made in the homework for week 1, and then pressure cook for 90 minutes. You'll want to make sure that you follow the directions for your pressure cooker. Don't hurt yourself and don't break anything. Follow the directions for your pressure cooker and be careful because you're dealing with hot things. Don't open the pressure cooker until the pressure has equalized, and don't burn yourself. If you don't have a pressure cooker, you can also do something called tyndalizing the grain jars. Over the course of 3 days, you will steam the jars once each day, spaced at 24 hours. So on day 1, you fill the grain jars, and then 1 day after that, 24 hours later, you put the grain jars in a steamer for 1 hour. You can use just a regular pot for this, as long as you put something in the bottom of the pot to hold the grain jars off the bottom so they don't crack from the heat. 24 hours later, you steam them for another hour. 24 hours after that, you steam them for a final hour. The way this works is that after the first day, heat-resistant spores that did not get killed by the original simmering of the grains will start to germinate. When they grow for about 24 hours, that's not long enough for them to make more spores, but it is long enough for them to be vulnerable to getting killed by heat. So when we steam it again, then it kills all of the living spores that had sprouted. Any remaining spores are very likely to sprout during the next 24-hour period and similarly get killed. And once you've done this for 3 days, you wind up with a jar that is essentially completely sterile, except in very, very rare cases. But either way, you need to either pressure cook your jars for 90 minutes or tyndalize with three steamings. And again, I wrote this up at fungalmaterials.org/grain spawn, so you can go through the steps there. And I also put up a couple other pages and videos about this stuff. And that wraps up today's lesson. The next week, we're going to talk about how to make solid fungal materials. So for instance, if you wanted to make an insulation panel, or if you wanted to make a bowl or a planter for growing plants in, we're going to talk about how to make that kind of material next week. For your homework, go to fungalmaterials.org/2018-workshop-1 and click on lesson 2. I will put up a couple links there with resources and read through those things because that will go into a little bit more detail than I did in this video. Second, start growing some kombucha. This is the easiest fungal material. It's actually a fungal bacterial material. This is the easiest one to grow. So you will be very richly rewarded for starting your experiments with that. Prepare a batch of grain spawn jars. With the mycelial materials, this is kind of more of a slow march. Last week we made the airport lids. This week we're going to use those to make the grain spawn jars. And then next week we'll start potentially being able to actually use those to make more fungal materials. When dealing with mycelial materials, there is more that goes into it than just kombucha, which only requires making tea. That's it for this week. Thank you for joining again. On Friday at 4 p.m. Pacific Standard Time, I will go live in the Fungal Materials group for questions and answers. If you send me your questions either in the group or via email ahead of time, I can be prepared. Otherwise, just show up and ask your questions and I will try to take care of them live. This work is released into the public domain under the Creative Commons Public Domain Dedication License 1.0. That means you can do whatever with it that you like. Resources for this lesson are available at fungalmaterials.org/2018-workshop-1/lesson-2. See you next week.